My name is Victor Lee. I'm from Lite-On Technology Power Systems. Lite-On is a Taiwan-based company, $8 billion company. We're a longtime partner with QCT. We provide the power system and SSD and other components. So it's been an honor here. Thank you, Mike, inviting us. So today, in the morning, we'll hear Mike and other presenters talk about a lot of the IT technologies, and we standardize the computing, storage, and networking, and the other are software bases. Then my topic will shift the gear a little bit. I'm going to talk about the infrastructure side. The infrastructure side is how to powering the hyperscale data center. Actually, the transformation doing the infrastructure side is a mirror image of a hyperscale HCI as well. So the future of the powering the data center really will be standardized hardware. The rest will be software based as well. So I have a quick agenda here, basically, and I'm going to talk about a little bit the market needs. And also, we also to emphasize the platform is the standard building block for the building the future data center. And also, I'm going to talk about next generation of the powering the data center and a little giveaway, takeaway. So, what is market needs actually? And from the data center, actually, this slide is kind of stealing from the Mike's slide earlier. Actually, what the customer wants from an IT technology, IT rack is similar for the infrastructure side. Customer wants your TCO. Your initial cost has to be lower, and your operation cost has to be lower. And you have to do very easy to scalable, so you need to modularize. And also, you have a building block. It's kind of metering utility, if you will. You pay as you go. Of course, the one you have complete the system. So complete system, not an integrated system, but also fully tested. Of course, lastly, you want your operating costs down, so you want your PUE really low, so your operating cost is low. So far, the Google and the Facebook data center, they get a PUE down to below 1.2, so they have come with that. So how we achieve that? So we have to come from the rack. So I'm going to walk through here. So what do I think is the rack and will be the building block and to achieve this. So the first, we're going to traditional IT rack. So traditional IT rack is a server with two power supply. So you stack it up, and basically what we call is distributed power architecture. You have two power supply, one goes down, means one utility side, one power supply goes down, the other one back it up. So this is traditional the distributed power architecture. Now to save cost and provide more flexibility, we put in the centralized. So what you can do, so you put your power supply, you remove it, so the rest is redundancy. So then what you can saving is you want the N+1 redundancy, then you put one in, and the rest is saving. That's what we call, this becomes the DC server right now. Now, in case you lose your utility, what's going to happen? You need a backup. So you can put a battery inside here. So this is a DC UPS. Actually, this is a different way. It's OCP structure. It's like a Facebook they started to begin with. Now we apply this architecture into the huge hyperscale data center. Let's give an example. Let's say 12 megawatts data center. Each rack is like 20 kilowatts. They have a 600 rack in the system. So the data center will be like this. The huge data center inside you have each rack. So the rest is what we call the facility side. Usually for the hyperscale data center, you have 2 feet come to the system. You lose 1 feet, then you switch the STS switch, go to the other side, and to provide the backup system. This infrastructure cost is very high. So you compare the IT technology, we standardize all the server storage networking, use computer, use a software-driven as application, as a services, what happened in the hardware world. Now we need to really get it improved. This is, we take a little bit close look on this, then how we derive this to simplify and how to power in the data center. So this is really the mirror image at a smaller scale about what we see the previous slide. The first, you can, the left-hand side, you can use some grid come in the UPS, then you go to the step-down transformer. The step-down is United States, you have voltage 220, 120. If for utility 480, you need to step it down. They have a transfer switch, then go to the traditional IT rack. The first step, what we're gonna do. So we put our traditional IT rack from distributed, go to the centralized. So that's, we can take out the PDU, which is the power distribution units, and the power supply become the centralized power. The next thing is, right, you want to further define. If you look at this, the data center, on the right-hand side is your IT rack. The left-hand side is your facility side. So what you're gonna do, to simplify this, you put your switch function into the power supply. Then if you can put your power supply input range from the 86 to 264 to 277. So what you can do, you really can simplify the architecture. So now you can see the first migrating to the rack. The next thing is your UPSs. Now, if we put your battery into UPS, voila. So here it comes. So your facility side really implement into your IT rack. So this is really your mini data center. You can scale up and can scale down. And what the advantage first is much simplified. You save your TCO cost, right, by 28%. You take out all the infrastructure out, you save efficiency by 7%. And also, you reduce the space. All the space you want, you can remove it. So this is really the obvious, the saving, you can see it. But come with it is that they're building two things. Because you have a battery, it's a lithium-ion battery technology built in. So you're working with your power systems, then you talk to your server, you talk to your storage. You can do the power management. So that's really the another side benefit. That's software and the firmware come in. So what is the next step? Next step is your IT rack on your right-hand side. You want to increasing your computing power. You want your increasing storage power. How are you going to do this? So we're going to introduce two technologies. One, what we call peak shaving. The other is a power capping. So what is a peak shaving and a power capping? If you look at the load, most of the time you run your server load like below 50%. Only have a peak time about like 100%. So let's assuming we have a rack. We said earlier, one rack is 20 kilowatts rack. You have a 42 42 server over there. Now you have a power shelf here. I double it. So basically 84 server over there. What's going to happen? Because in steady state, you're running below 50%. So steady state, you'll be okay. You can, normal operation, you can double your computing power. But what happened, you have a peak power. What's happened now? My battery kick in. So your battery kick in, you discharge it, discharge the battery, then you're running below 50%, your system start to charge your battery. So this is the peak shaving. So this is one area you double your computing power by use this technique by managing your battery, manage your load, manage your power system, integrate doing power management. Is this good enough? No. We're going to have another insurance. Why you do this? Because this we may miss something. So what you can do, what we call power capping. So power capping, what the power capping means, when the computers start doing the running the more than 50% load, you sensing the loading. You know it's coming the heavy load. So what you can do, you can, Intel server already built in, you can slow down your frequency. Slow down your frequency, that means you reduce your loading. The second thing you can do, you reprioritize your loading. You sequence your load. So then that's what we call is power capping. You reduce the load. Now, what we can do is this. In order to double your computing capacity or storage capacity, you can integrate these two things. You integrate the peak shaving, and the power capping. The benefit, you can reduce the utility cost. Also, you increase your computing density. So what I call this is virtual power on demand. So this is kind of mirror image, mirror image. It's in the power of facility side, the IT world, they're using the virtualization to virtualize the server, virtualize the storage. In power world, we always can do that. So we standardize in the rack, IT world standardize. So this HCI, basically all the powering the super hyperscale data center is really followed as mirror image technology-wise. So here is my little takeaway. And first, we kind of standardize both the IT technology and infrastructure. We standardize in the rack level. The rack is a platform for the future data center, and also for the next generation. We can next generation peak shaving and the power capping will give you greater computing density. And what we're seeing a new way to power hyperscale data center is a virtual power on demand. This is my little story. Hope you enjoy, and thank you for your attention.